Few places hold as much power and mystery as the inhospitable realm of space. For centuries, it has beckoned us to seek ever deeper for answers to our most fundamental questions. Where did life begin? How did our tiny planet come to be? Are we alone? To unlock these secrets, we must look beyond the visible, into the dark, cool matter at the edge of the universe. Humans have been unable to peer into this secret world until now. High in the Atacama Desert in Chile, the observatory that will revolutionize our understanding of the universe is under construction. This desolate moonscape is no place for the meek.
We're building ALMA at 5,000 meters altitude in a high desert plateau in the Chilean Andes. And absolutely everything associated with the civil engineering at that altitude is difficult. The receivers that are actually detecting the radio signals from space are incredibly sensitive. They have to be cooled to only 4 degrees above absolute zero and contain so-called superconducting detectors. Literally more superconducting detectors in the ALMA telescope when it's completed than have been built in the entire history of mankind.
Nearly 24 hours a day, native Andean workers lay the foundations for ALMA's 66 giant antennae. Negative 15-degree temperatures and winds over 60 miles per hour confine their work to large indoor tents. The telescope's instruments are so sensitive that these concrete platforms must be within a fraction of a millimeter of perfectly level. To support its hundreds of personnel, the ALMA team has had to build its own fully functional city at an altitude as high as the base camp of Mount Everest. Scientists and engineers have spent nearly 3 decades developing the groundbreaking technologies that will allow ALMA to see deep into unexplored space. The multi-billion-dollar telescope will possess 100 times the sensitivity and resolution of its predecessors.
ALMA is sort of a perfect storm of all kinds of advanced technologies coming together at the same time.
Among the most impressive advancements is the ALMA correlator, the most powerful civilian computer ever created. It has the processing power of 150,000 personal computers combined. To make its most precise observations, the telescope's antennae must be positioned to within nanometers of a certain spot on an 11 square mile plateau. To achieve this, engineers have designed and built specialized antenna transporters, each weighing over 140 tons. They have onboard generators to keep the antenna systems working on the moon. Beyond the extreme feats of engineering, ALMA faces unique political and environmental challenges.
The project is so complex, yet everybody's managed to come together. We have people from Japan and from Europe and North America and Chile all working together. So many people that if they'd been housed in San Pedro, it would have significantly changed the nature of this Chilean tourist adobe brick building village. So in order to meet the environmental requirements of not impacting the local area, we've literally had to build our own city, our own village.
The greatest observatory in human history is on the verge of becoming operational. As the project works through its most critical phase, the entire careers of its chief scientists and engineers are on the line. But the potential rewards are as great as any in history. It is estimated that more than half of all the matter in space lies within the unexplored spectrum that ALMA will observe. We will finally be able to watch as the base molecules of the cosmos interact to form stars, galaxies, and, scientists expect, the very seeds of life. We will see the outer limits of space as never before, staring back some 13 billion years to help unlock the mystery of how the universe formed. And we will see deep into closer objects, like our own sun, to witness events we have only theorized. But ALMA's greatest discoveries will undoubtedly be those that we cannot foresee.
The ALMA telescope, when it's completed, will literally revolutionize astronomy. It will be such a leap forwards compared to anything that we've ever been able to do in the past that we will almost certainly find things that we've never expected to discover.